This really important homework. This was a mega homework, and I'm hoping that y'all have questions because I would love to work some of these. You can also check out the homework help tab on my website because I worked 3 of these on the homework help. I want to at least do 1 of them that involved trig, so make sure you ask me about 7, 12, or 14. Because those, you had to do trig on each of those. We are looking at number 8 from the Polygons 2 homework. Find the area of a regular hexagon with an apothem of 3√6. So you can draw the whole hexagon, or honestly, you can just draw this little triangle every time. That little triangle is made up of an apothem, a radius, and half of a side. That's what that triangle is made up of, and it's the key to all of our problems. The apothem is 3√6. We know area is apothem times perimeter divided by 2. So we don't need the radius. All we need is a side. The side will get us the perimeter. So 3√6 is across from 60. So how do you undo x root 3? Well, you divide by √3. Whoa, look, this doesn't happen very often. Those radicands are divisible. 6 is divisible by 3. 6 divided by 3 is 2. So, across from 30, that is 3√2. Is that the side? No, it is not the side. It's only half of the side, so be careful. The side is 6√2. So now we're ready to go to our formula. Apothem times perimeter, side times number of sides, divided by 2. Apothem times perimeter divided by 2. I'm going to multiply all of my integers first. 3 times 6 times 6 divided by 2. I get 54. Now I'm going to multiply my radicands. 6 times 2. They're both in a radical, so you're allowed to multiply them. I'm not going to leave that as my final answer because I know that 12 is 4 times 3. 4 is a perfect square. It escapes jail as a 2. So I have a 2 out here times 2. So I have 108√3 as a, just so that it's prettier for our purposes. Okay, the side is 2. So we're going to draw our apothem, we're going to draw our radius, and the side is 2, like we said. Okay, so we need an apothem, we need a perimeter, and then we'll divide them by 2. We know that this is 1, but this is not 30, 60, 90, so we're not going to use any shortcuts or rules. We're going to have to do trig. Now, I talked about yesterday how there's 2 ways to find the missing angle. You can do n minus 2 times 180 divided by n, and then divided by 2. Or you could do 360, because there's 360 degrees in a circle, divided by double the number of sides, because you have 2 triangles per side when you draw the apothem and the radius. So we would do 360 divided by 16 for this problem. There's 8 sides, so we're doing 360 divided by 16. We did not find this angle right here. We found this angle, and it's 22.5. We don't need the radius, we need the apothem. So I'm going to put x here. And now we're going to do trig to find our apothem. So we have, this is the angle, we have opposite, and we have adjacent. So we're going to use tan. Tan of 22.5 equals opposite over adjacent. Denominator divide, 1 divided by tan of 22.5. And we're going to keep this in our calculator. 2.414 blah, 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 blah. I wrote it down there, but I'm going to use the whole decimal as I'm calculating this, okay? Right here in my calculator, I have the apothem. I have the apothem. Now I'm going to multiply it by the perimeter times, what's the perimeter? Let's see, each side is 2, and there's 8 sides. So the perimeter is 16, so I'm doing that apothem times 16 divided by 2. 19.31. Did we have units? Nope, just units squared. 19.31. I just wanted to show the answers to the area and perimeter quiz. You can figure out really quickly which version was your version, because I want you to know what you did wrong if you did anything wrong and be able to ask your teacher about that. Okay, so correcting what you did wrong on this quiz is really important moving forward and getting to our area and perimeter test. So pause this and look at the answers if you need to do that. All right, today's lesson, we're finally at the lesson, is circumference and area of a circle. So get your notes out, get your little formula chart out. You've already seen this stuff. This is not like yesterday where you had never seen the formula for a polygon before. Now you've seen this stuff, so we're just going to make it K level. So here you go, circumference of a circle. You know this, it's either 2 pi r or pi d. Those are the same formula written different ways. Sometimes you're given the diameter and sometimes you're given the radius. Quan found the pi symbol, good job. Cute, okay. The formula for area is pi r squared. What's really cool is, I mean, this works with any shape, but you can see it better with a circle. You'll learn about derivatives in pre-cal, either pre-cal or calculus, I don't know when they teach it these days, but the circumference formula is the derivative of the area formula. The way that you take a derivative is you take the exponent, you multiply it up front, and then you subtract 1 from the exponent. This is just so cool, I love math. So the 2 falls here, and you got your pi r, but 2 minus 1. So the area formula, you take the derivative and you get the circumference formula. I just think it's really cool. Anyways, math majors exchanging high pies. Ha ha ha, get it? Instead of a high five, they're exchanging high pies. Really nerdy. Okay. I just want everyone to know that pi is not a unit. Some people accidentally start treating it like a unit, like centimeters or inches. You know that pi is a number. Why are we using a symbol for it if it's a number? It's because it's a really common ratio, and it shows up so often in math that it got its own name. It's like a celebrity to numbers. It's a celebrity, just like E, but we don't use E in geometry. Anyways, so pi is an irrational number that goes on forever and ever. Well, as far as we know, sorry, ignore that. As far as we know, it goes on forever and ever. Here are some of the decimal places of pi. Just some of them. There are computers out there that just, all day long, they just calculate more decimal places of pi. I'm trying to show it to you. Oh, there we go. There's some of the decimal places of pi. Isn't this like mind-blowing? Anyways, pi is just a number. It never repeats its sequence. It's called irrational. And it's really, pi is actually just a ratio. Let's talk about what the ratio is. Oh, let's talk about it because I don't have a slide for it. So, how do you find the circumference of a circle? Circumference is pi times diameter. Solve that for pi. Good, Rishi. So let's solve this for pi. Solve it for pi. That means get pi all alone. So you would divide both sides by d. So pi is the circumference over the diameter. It's so innocent. Pi is just how many diameters does it take to make the circumference. So if you have a circle, the number pi is simply how many times can I wrap the diameter around the circumference. Well, I can wrap the diameter 1, 2, 3 and a tiny bit more. 3.1415, you know the drill. That's what pi is. It's how many times can I wrap a diameter around a circle. That's all it is. I can wrap it around 3.14 times, okay? So pi is pretty innocent. It's not as scary as you think, but it is a number. So if you put your answer, if the answer is 3 pi, and you leave off the pi, you're going to get it wrong because it's a number. It's not just units. It's not like you just left off inches. You left off part of your answer, part of the number, so you would get it wrong. Okay, Emily is riding bikes with her daughter. Emily's bike is a 23-inch bike, and her daughter's is a 16-inch bike. How much further does Emily's bike travel with one revolution of the wheel than her daughter's? So bikes are measured by what? It's just like pizzas. If I say a bike's a 23-inch bike, what does that mean? It's the diameter of the wheel. It sure is. Pizzas, when you order a pizza, if it's a, I don't know, 10-inch pizza or whatever, that would be the diameter of the pizza. 14-inch, yeah, 10 would be kind of small. Okay, so what are we looking for here? Are we looking for area? Are we looking for circumference? We're looking for circumference because it's the revolution of the wheel. So we're not filling it in, it's not area, it's circumference. So we're going to do Emily. Subtract their circumferences. Simple, 23 minus 16. And we get that the difference is 7 pi. But this is a real world problem. So 7 pi, that's called in terms of pi. That would be the exact answer. But since this is a real world problem, in the real world we don't talk about lengths being in terms of pi. So on this one we can actually press the pi button. 7 times, and we're going to press the pi button. We're not going to use 3.14. We're not going to use 22/7. Throw those out the window. We use the pi button. So 7 times the pi button, and we get the real world answer, 21.99, so pretty much 22 inches. That's how much further, every time she pushes her foot down and the bike goes around, she goes that much further every time. So that daughter is going to have to spin her legs a lot faster to keep up with her mom. The circumference of a circle is 30 pi. Find the area. The circumference of a circle is 30 pi. So we take our circumference formula and we set it equal to the circumference. What happens to the pi's? The pi's will cancel. We don't even have to worry about them. So now we're going to find the radius. We're going to divide both sides by 2. The radius of this circle is 15. Once we know the radius, we can find the area. Pi r squared. We know that 15 squared is 225. So the final answer is 225 pi. That is the area of the circle. We are not going to press the pi button. Just like most of the time, I would never tell you to press square root of 2 in your calculator. You keep it exact. You keep it 3 root 2. In this one, we're going to keep it exact, 225 pi. We're not going to use 3.14 or press the pi button, unless it's a real world problem and it tells us to round. Find the circumference of the circle. For circumference, you need a diameter or a radius. We have neither of those. So we're probably going to need to draw our little apothem radius triangle. Okay? So let's go ahead and sketch the apothem and the radius. We are looking for r. We need the radius. Is this one a special case or not a special case? Is it 30, 60, 90 or not? It's a hexagon. So it is a special case. So this is 9. 9 is across from 30. So what's across from 90? It's 18. And we actually talked a little bit yesterday about how in regular hexagons, the radius is equal to the side. That's not a coincidence. That doesn't just happen sometimes. That's all the time. But it's only for hexagons. So don't think that that happens in triangles or other shapes as well. Just regular hexagons. Okay, so our radius is 18. We need the circumference, 2 pi r. So our circumference is 36 pi. If you leave off the pi, you get it wrong. Don't leave off the pi. 36 pi. We're not going to put it as a decimal. We're going to keep it just like that. Ooh, this one's pretty, huh? You like the Burberry print I put in there? Find the area of the shaded region. You're going to be finding lots of shaded regions in the future. So this is the strategy that we will employ every time we find a shaded region. You're going to find the area of the larger shape, you're going to find the area of the smaller shape, and you're going to subtract them. Okay, so we need to find the area of the whole circle, the area of the whole circle or the large circle, and we're going to subtract the area of the smaller circle. Okay, so the area of the whole circle is pi r squared. The area of the smaller circle is pi, what's r? What is r in the smaller circle? 3.5, yep, pi r squared. So we have 49 pi minus, this is going to get a little ugly, question. Is that my final answer, or am I allowed to combine them? Stop, everyone wait. Quan is asking. We're assuming that 7 is the radius. Let me tell you something. Oh, bye, Truett. Let me tell you something about this dot. When you see a circle and you see a dot like that, forever and ever for the rest of time, you're allowed to assume that's the center. When you see a dot, that is the person indicating that is the center, okay? That is the center of the circle. You don't have to assume, you know it is. When you see a circle and there's a dot inside, that's the center. So in our calculator, we're allowed to combine these because these are both, they're like terms. They both have pi. 49 minus 12.25, and we get 36.75 pi. We could also do math enter, and do 147 over 4 pi. Those would both be accepted answers. We are not going to press the pi button. Find the area of the shaded region. Don't really have time to pause anymore because we're running out of time. So we're going to find the area of the circle minus the area of the square. The area of the circle is easy. Pi r squared. The area of the square is a little bit harder, but not by much. We're going to be strategic, and we're going to draw this right here. We know that we just made a 45, 45, 90 triangle. So the side of the square is 4 root 2. The area of the square is side squared. So I'm going to take the side of my square and I'm going to square it, same as base times height. Okay, so this is 16 pi minus 4 squared is 16. The square root of 2 squared is 2. 16 times 2 is 32. And believe it or not, that is the area. You do not combine them because they are not like terms. You can't combine something with a pi with something without a pi. 16 pi is bigger than 32. Okay, last problem. This one's a little weird. Find the exact area and perimeter of the shaded region. So the shaded region is going to be the yellow region. So, how many circles do we have? How many circles? Good. We don't have 1. We don't have 2. We have 1.5 circles. We have a half, and a half. So guys, this is not bad. We're going to find the area and we're going to multiply it by 1.5. We're going to find the perimeter, and we're going to multiply it by 1.5. Well, the circumference, okay? So let's do the circumference first. If I travel, this is going to be half a circumference, half a circumference, half a circumference. You are allowed to assume that those are semicircles because they can't be anything else because we don't know how to find the area of anything else. Okay, so we're going to do 1.5 times the circumference. Now, if AB is 16, is that the radius or the diameter? It's the diameter. So the circumference is pi times diameter. The circumference is 16 pi. 1.5 times 16, the perimeter is 24 pi inches. Area, pi r squared. There's 1.5 circles. So we're going to multiply that by 1.5. We're not going to press the pi button. 8 squared times 1.5. 96 pi inches squared. Here's what you would never ever do. Are you watching? 96 pi squared. Bad, wrong, bad, never. There is never a reason for us to square pi. Ever. You square your inches because you're 2D, area's 2D, but you never square your answer. You never square pi. Pi is a number. It's not a unit. Okay, have a great weekend. That's it.